Okay, so we just finished setting up the project for the coastal training modules, and now we're going to run through the Create a Grid module. So let's move this out of the way because we don't need it for now. What we need to do now is to do the Flow 2D setup. So click the Flow 2D wrench tool and click Create. Now you can put this directly into the coastal training. So if you can't find it, remember we added that to quick access already. So just go to coastal training. We will call this coastal project just to keep it safe. Whoops, sorry. And then once the next thing that's going to happen is that the coordinate system is going to pop up. You probably won't see all this stuff in here because you haven't barely started using QGIS. So we want to use 2881 as our filter just to minimize and eliminate all that nonsense that was in there. And then check or click on the one that we want. And as you can see, it should match this guy right here, 2881, and then click OK. Now that will build the geo package and build the layers. And you can see here that we have the correct coordinate system and the units are feet. And so we can set this to 20 because we want a 20-foot grid. Whoops, 20, not 22. And then click OK. And now the plugin has loaded. So the next step in the tutorial is to create the grid. Now while I'm going to go ahead and click Create the Grid from an external polygon, and I want to use the project area of interest as my polygon. So these are alphabetical, so if I come in here, I can just hit the P key and it'll take me right to the P's. Select that. It also has a cell size field with a cell size in it of 20 and click OK. And then while that is processing, I'm going to go over to my other screen and just make sure I'm on the right step. So step one is to, let's see, create a grid. Step one is to set up the project. That's what we just did with the geo package. Step two is to create the grid. And that's what we're waiting for now. That takes about 30 seconds. And then we can move on to step three once that's finished. But before I move on to step three, I did want to note that if you do not have a project area of interest shapefile like this one, that's okay because you can create that you can create that in your computational domain. So if your computational domain is empty and you don't have a project area of interest shapefile like that, you can just select this layer and edit right here and then add a polygon right here. And then you see here how easy it is to add a polygon. So if I just click, and right click, that's add a polygon. So you would just want to make that polygon the shape of your project and then put your cell size in and click OK. And then instead of using create grid from external layer, you just create the grid from the project domain instead. Okay, now our project grid is set up and ready. And the next step is to, the reason I give you guys this and don't have you make this on your own is because I want everybody to be on the same page for the training. So the next step is step three is to save the project. So that is click save here. And then again, we're going to put that right into coastal training and just call it coastal project. And click enter, and that will save it. And now you have a QGZ, which is how you open and load data into QGIS. That's a QGZ file. And you have a GPKG, that is your Flow 2D project. We'll see that more in a little bit once we get to another part of the lesson. Okay, so step four is to assign the grid element elevation. So let's grab our training folder and get back into our project data. And in the AOI folder, we have elevation and manning. So I'm going to grab well, actually, let's see. I'm going to grab first I want to click the computational domain layer, and then I want to grab the elevation raster and drag it onto the map space. Now you can see here that it covered my grid and my computational domain. So if you want to get that back, you can click the layer, drag it over down here to the side until that icon changes from the Ghostbuster symbol into the arrow, and then drop it. That'll move that layer to the very bottom of the map. And then I come down and I just click it again because the next layer I add will go right on top of it. Back over here under the elevation tools, we have a sampling elevation from a raster layer. That's the one we want because we don't have points, we have a raster layer. We only have one raster at this point, so I'm just going to click that, or just use that, and then click -9999 because this will be the no data value for the interpolated raster. We'll use an average of all no non-data pixels, and then just click OK. That takes a few seconds to run. And while that's running, I want you to note that we now see this elevation raster of interpolated file. Now this one is the one that gets positioned right onto your grid, or I'm sorry, this is the exact same dimensions as your grid, and it's also has the single elevation value that gets interpolated from this raw data. Okay, now we'll click sampling done and click OK. And let me get back over here onto the steps and see what's next. So the next one will be to assign the roughness data. So we'll need the roughness polygons, and we can get that from the Manning shapefile. So you just drag that on, and note when I drag that on, it puts it right on top of the elevation raster. So that's why I selected that layer before I drag the data on. Now, Manning's data, the way that we assign it to the grid is through the Manning's polygon roughness sampling tool. And same as the elevation, we'll select the layer. In this case, it's all the way at the bottom because it's the last one. So this one isn't alphabetical, but you can still do the same thing. You can still hit the M key. It'll take you right to it. And then I hit enter. And then the field is, in this case, I only have one field, and it's Manning's N. Probably better to use a centroid point sample because it goes quite a bit faster on a large project, and so I kind of recommend it unless you're working for, unless the project specifies that you have an area weighted average, go ahead and just use the centroid point sample. That should take around 17 seconds to complete. And let me move down into step 6 so I'm ready. Okay, so now once this completes, we'll be ready to look at the data and then move on to step 6. So it takes about 17 seconds here. And then what I want you to know is when we process these two layers, what they do is they get assigned directly to the grid layer, which is right here. So your grid layer is a schematic layer, and it has this data in it. Now you don't want to open the attribute table of this because that'd take a really long time to load that attribute table, and there's better methods for filtering and finding data in this layer. So just a note, probably don't want to open the attributes table on that if you can avoid it. But what you can do is you can use this guy right here, and you can click any cell in the project, and you will see that it will give you the grid element number, the elevation value, the N value, and the cell size, and the total number of cells. I'm going to turn these two off so you can see that another thing that it does is it will also render the elevation. And one final thing about this is if you hit a specific grid element in here, or you enter a specific grid element in here and you hit the I, it will zoom right to that element and highlight it. And then you can zoom out with your roller wheel to put that, to see the details of that specific cell. Now, if you want to zoom all the way back out to the full project, you can select the computational domain layer, right-click, zoom to layer, or you can use this icon right here, and that'll zoom you back out to the full project. Rendering the elevation slows things down, so if you want to uncheck that, that's fine. Now, the final step, well, maybe not the final step, I think we have 2 more steps, is to assign the control variables and save the project and then create a backup. So we have 3 more steps. So control variables, that's the controls to run the model. You can get to those from here. And this project is pretty small, so 24-hour simulation time will give it plenty of time for the rain simulation to start, the rain to peak, and then the model to drain because it's a small project. If you have a bigger project, this might need to be 36 hours or maybe even 48 hours. Or if you're modeling a bigger storm, like a multi-day storm such as a hurricane, again, you probably just want to set this to the hurricane, and in a hurricane it'd probably have plenty of time to drain it because your model time might be a day or 2 days, whatever. 0.1 is our output interval. If you have this at a really high, like a 48 hours or longer, then you might want to consider using an output interval that's a bit higher, like a half day or something, or half hour or an hour. Because there are over 200,000 cells, the model will always default to the text screen mode. So you won't see the model running in display graphics. We can use a limiting fruit of 0.9 now. Now what that's going to do is it's going to, if you are running Flow2D and any cell becomes supercritical, in other words, it has a Froude number of 1 or higher, then the model will automatically make a minor n-value adjustment to that cell, because we are specifying right now with this variable that we don't think that our flow in this area can go supercritical unless it's going over a hydraulic structure or a drop structure or something like that. And if that's the case, we can change the limiting Froude in the channel, or we can set a spatially variable limiting Froude. On to the next tab. So that's all we need for control variables because we don't have anything else going on. It's just a grid at this point. So on to the control, or the taller.dat, the numerical stability parameters. If you have a model that's urban modeling and it's urban overland, and you want to use a low surface detention value of 0.004, that's probably okay. But I don't like to use it for training because it can cause instabilities that you would then have to go fix. So I like to put it to 0.01 feet. And what this means is that every cell will have to fill up to 0.01 feet before it can change flow with its neighboring cell. So it's a surface detention, much like an initial abstraction. And if you're using an initial abstraction in your model, you'll want to account or to recognize that you already have a default of 0.01 for every cell. So if you have something higher, an initial abstraction that's higher than 0.01, just subtract this out of that value and use that as your final initial abstraction value. These are the other two important variables in this file. The Courant number on the floodplain, we default that to 0.6, and that's usually just perfect for stabilizing flow on the floodplain. Now, if you find that you have unstable flow on the floodplain, like high velocities that shouldn't be there, or lots of n-value changes that are a little bit too excessive, then you can set this down an increment. So you would start at 0.6 and then maybe move down 0.5, 0.4 to try different runs. But typically the floodplain stabilities are okay unless you have ponding, because the models are so flat, the water's not really moving, so the numerical stability only becomes an issue if there's ponding. If you have a numerical instability in your channel, then this is a little bit different. So you would start at 0.6 and then go down by increments of 0.2. So instead of going to 0.5, you just go down to 0.4 or maybe 0.3. Run it again and see if that helps with your unstable channel. So I'm just going to leave them both at default for now because it should be fine for the training package or the training lesson. And finally, after we set those up and hit save, they are committed to the project. And then we can hit the save button again here. Now what happens when I hit save right here is that the project will save the QGZ file, and all that's doing is making sure that the next time you load the data, this Manning's N layer and this elevation layer are also brought into the project. It did not save the geo package. So it remembers whether or not they're checked and their position in the layers and that they exist. Okay, so let's go ahead. Now that we saved that, the next step is to actually close QGIS. So I wanted you to pay attention to these two things right here when I close QGIS. So as you can see, those two GeoPackage journaling files have disappeared, and the data that was in them have been a final commit to the GeoPackage database. So now, if we want to do a backup or a recovery point of this, we can just select these two, right-click, and send them to a compress zip folder. Now, if you happen to have if you happen to have 7Z zipping tool, then send them to a 7Z because that makes them a lot smaller. So now if you continue on to the next step, which is hydrology, and you made a major mistake in the hydrology, it's something that you couldn't undo and you couldn't redo it, you basically destroyed your geo package, then you can delete these two and then extract from here and replace them, and then you could just start over. So that's the point of a recovery pile. And I typically will build a recovery backup every time I'm finished with something important like channels or culverts or buildings or something that you can't, if you were to destroy that data accidentally, you could get it back. And then to get back into QGIS, the final step is just to open QGIS back up and reload your data. I have an error message there that comes up because one of my plugins is not happy with QGIS. And so now you don't actually have to, you can either do this and drag it back on, or you can just grab it from here and double click it and wait for the model to load, say yes, and the model will load. And that concludes this module to create a grid, and the next module will be hydrology.